Hello everyone, welcome back. This is the fourth video for Core Java interview questions. In case you want to check the previous videos, you can access the playlist from top right corner. Also, I'll provide the link in description as well. In this video, we will cover 15 more questions on Core Java and we'll see how we can answer them in the interview properly. If you are new to the channel, please go ahead and subscribe and don't forget to press the bell icon so that you won't miss any new videos. So without any further delay, let's start. The first question is why the main method is static and can we execute a program without main method? So as we all know in Java, main method is a very important method. So in its signature itself, we are specifying static as well. So the question is why that main method has to be static? The main method is static so that the compiler can call it without creation of object or before the creation of object. So if you know static variables or static members in a class, they do not belong to any object. Only using the class name itself we are able to access. So if we want to execute a particular class using JVM, so JVM need not to create any object of that class before executing it. So that is why the main method is static in nature. The second part of the question is, can we execute a program without main method? So with this question, actually interviewer wants to test your knowledge of previous versions of Java as well. So before Java 7 or JDK 1.7, we were able to execute the Java program without main method also using the static blocks. But from Java 7 onwards, this thing is not possible. It will give you an error if you try to execute a class without main method. Next question is, what if we remove the static modifier from the signature of the main method? So continuing with the main method questions. So what if we remove the static modifier? What will happen? Will it give any compilation error or how the program will behave? So actually for the compilation thing, it will not have any impact. It will be getting compiled very properly without any compilation issues. The issue will come when you try to execute that class when you want to run that class in Java. So in that case, it will throw you an error that it is trying to find out main method but unable to find in that particular class. Next question is, can we override static methods and justify your answer also? So overriding is a concept of polymorphism that happens between a base class and a child class. So if a method is already present in the parent class, its implementation is present in the parent class, then the child which is implementing that parent class, they can provide their own implementation of that method as well. That particular phenomenon is known as overriding of the methods. So here question is, can we override a static method? So suppose in parent class method is statics. So will you be able to override its implementation in the child class? So answer to that is no. The reason behind that is method overriding is a dynamic binding that happens at runtime. But if we see in case of static methods, those do not belong to any object, they belong to classes and they are getting bind at compile time. So due to that reason, we cannot override the static methods. Next question is, what is the need of marker interface in Java? So you might have come across various marker interface like a clonable or serializable. So what is the actual need of that particular thing? So marker interface is actually just used as a tag that informs the Java compiler that it can add some special behavior to that particular class which it is implementing. So suppose if we want to make a class serializable, we want to store its objects to the byte stream or files, we must implement the serializable interface. So when we do implement serializable, then Java compiler will come to know that yes, this class can be serialized. So it has added that special behavior to that particular class. Similar for the case of clonable interface as well. Marker interfaces are nothing but just empty interfaces. They do not contain any method which the implementing class needs to override. Next question is how to create an immutable class in Java. So before that, you need to explain what exactly is an immutable class. Immutable class in Java means that once an object of that particular class is created, we cannot change its content. The best example for that is string. So we know if we define a string and after that if we want to change its value, we'll not be able to do that. Suppose there is a variable str and we assign it a value of abc, and on later stage we assign abc is equal to xyz. In that case, abc will not be changed to xyz. Instead, another object xyz will be created and reference of that str will be pointing to xyz. So now let's see how we can create an immutable class. So there are particular steps or few things we need to note while creating our class if we want that class to be immutable. The first one is we need to declare the class as final. Why do we need to do that? So that the child classes cannot be created. So the other classes should not be able to extend that particular class. So in that case, we need to declare our main class as final. The second point is all the data members should be number one private. Why private? So that it cannot be accessed outside the class. And second is final. Final means once we assign a value to it, its value cannot be changed. So these two properties are very important for all the data members. The third point is a parameterized constructor should initialize all the fields performing a deep copy. So concentrate more on this word deep copy. So why do we need to perform a deep copy? So actually if you see, there are two types of copies that we can do in Java. One is shallow, other one is deep. In case of shallow, actually a new reference will be pointing to the same object in the memory. But if we perform the deep copy, it will create a whole new object itself, and a reference will be pointing to that newly created object, so that whenever we make changes in the previous object, it will not affect the newly created object. So we need to make sure whenever we are initializing the fields, we should perform a deep copy so that the changes in old object should not impact the new object as well. The last point, there should not be any setter functions for the fields. So why we need to do that? So if we define some setter function, that means we are changing the value of the fields. So that is actually going against the rule of immutability. So setter functions should not be defined in the class. So if we follow these steps itself in a particular class, then we could say we have created an immutable class. So after that question, the next follow-up question could be, what are the advantages of using immutable objects? So an immutable object remains in exactly one state, the state in which it was created. Therefore, immutable objects are thread safe. Immutable objects are good map keys and set elements. So since these typically do not change once created, so they are the best candidate of map keys. That is why string is considered as best key for mapping. Next is immutability makes it easier to parallelize the program as there are no conflicts among the objects also. The internal state of program will be consistent even if you have exceptions because it cannot change its states. The reference to immutable objects can be cached as they are not going to change at all. Next question is, what was the issue with substring in JDK 6 and prior versions and how to fix that? So suppose there is some legacy application which is still using JDK 6. There was one issue with the substring function before JDK 7, like JDK 6 and before versions. There was some issue with that substring method. So what was that issue and how to fix that? In JDK 6 and before version, substring was one of the main causes of memory leak. So memory leak is a very important concept. I have already created one video on the memory leaks in detail as well. So if you like to check out, please check it on the top right corner. Otherwise, I'll also provide the link in description as well. So how does substring was actually causing the memory leak? So if you see the structure of string class, it is nothing but a few offset variables. Then we have hash, and then we have a byte array. So byte array is something which is storing all the characters of that particular string. So whenever we used to do a substring, what it was doing, it was setting a few offsets, like we want to have a substring of index 0 to 2. So what it was doing, it was sharing the same byte array with the different offsets. So suppose I have a string of size, suppose 1 billion characters. So it will have a byte array of size 1 billion. And suppose I want to do a substring only for 2 characters from 0 to 2 or 5 characters suppose. So in that case, the whole 1 billion byte array that will be shared across the main string and substring. The substring reference will also point to the same byte array. And now suppose we do not need the whole string of 1 billion size. So what we'll do, we will just assign the main string to null. So we are thinking that it will be garbage collected, but that was not happening. Why? Because the substring was also pointing to that particular byte array. So due to the active references to that particular object, that whole byte array was not getting garbage collected, and we were only using it for 2 or 5 characters. All the other characters are remaining in the memory even when those are not needed. So that led to memory leak. So how exactly that thing was handled by the programmers at that time? So for that, while creating a substring, we are using a new keyword, so new string, and then pass str.substring in that. So in that case, if you see in the first line here, it's creating a substring and pointing the sub str references to that newly created substring and also to the byte array. But here in the fix, if you see, we are not assigning str.substring to anything. We are just fetching it and creating a new string out of it using new keyword. So with that, once the bigger string is not required and assigned to null, the whole byte array that will be eligible for garbage collection. This thing was already taken care from the JDK 1.7 itself, and new strings are getting created every time when we do when we use substring method. Please do let me know if any of these questions are not clear. I'll try to explain it. Next question is how to avoid null pointer exception while comparing two strings in Java. Now let's see how we can do it. So first point is always call equals method on known string which is not null. So suppose there are two strings and we know one of them to be always not null. So how we should be comparing? We should be comparing that non-null object dot equals and then the other object which can be null. So in that case, we will be able to minimize the null pointer exception. So let's take an example. Suppose we want to compare one variable type with one of the string literals. So we know that string literal is never going to be null. So what we should do, we should do string literal dot equals and then that string object. So that will make sure the null pointer exception will never come even if the comparing object itself is null. Second one is prefer value of over two string where both return the same result if we can get the same value. Next is avoid returning null from a method. Instead, return an empty collection or empty array. So suppose in your method itself, you have a return type of collection or an array. Instead of returning null, try to return the empty collection, collections.empty, or an empty array itself, so that the calling method should not face the null pointer exception. Next one is using null safe methods and libraries. So there are various libraries available, just like string utils we have. So in string utils we have is blank, is numeric, is white space. So using all these methods, we can make sure that before applying any operation to that string object, we should be able to guess whether it is null or not. So using that validation, we can avoid the null pointer exception. Then we have use of optional. So from Java 8 onwards, they have already provided a wrapper class of optional. So we can make use of that to minimize the null pointer exception. The last one is use non-null constraint on the database. So anyway, in our applications, we'll be storing the data to databases somehow. So we can make sure that non-null constraints are already applied to the database so that the null data itself is not getting added to the database, so that during reading that data, we will not be getting any null pointer exceptions. The next question is it possible to call a constructor from another within the same class? So problem here is like we have one class and we have multiple constructors. So that means constructors are overloaded. So is it possible to call one constructor from other constructor? Answer to that is yes. It can be done using constructor chaining. So what exactly is constructor chaining? It is the ability to call a constructor inside another constructor. We can override the constructor with different arguments as we have just discussed. And to call the other constructor, we can make use of this keyword. So using this keyword, we'll be able to call the constructor. Now let's check that with an example. So this is our class sample. It is having three different constructors with two instance variables, number and name. In the default constructor, we are not assigning anything, just printing one line that a Noah constructor is called. And in second constructor, we are passing one integer and setting the number, and also printing that it is setting the number. And if you see the first line in that, we are calling this keyword here. So this particular line will call the default constructor of this class. Similarly, if we see the third constructor, we are passing the two values, name and number here. And if you see the first line, this we are passing number here. So which constructor it will call, that depends on the argument that we are passing. So here we are passing number, which is integer. So the second constructor will satisfy this condition, and using this line, the second constructor will be called. So when we create an object in our main class, main method, we are passing both the values, and it will start its execution from the third constructor because it is satisfying the number and type of arguments here. And then from the first line itself, by passing the number, it is calling the second constructor. And from the first line of second constructor, it will call the default constructor. So in actually the flow of execution of constructor will be default constructor, then constructor with one argument, which is integer, and then the complete execution of third constructor with name and number passed. So if we see the output, so first nowhere constructor is completed its execution, then it will return back the control to setting number constructor, and after in the end it will send back the control to setting the name as well. So this is how constructor chaining works, and we can call one constructor from the other constructor. So if you have already mentioned that you have some experience working on the multi-threading applications in Java itself, so the interviewer might ask you to state few disadvantages of using multi-threading in Java. So you can mention these disadvantages to them. First one is complex debugging and testing process, overhead switching of context because there is a lot of context switching between the threads, so that is one of the overhead. Then we have increased potential for deadlock occurrence. Definitely, if multiple threads are trying to access multiple resources at the same time, then it is highly probable that deadlock could occur. So that increase the potential of deadlock occurrence. It increases the difficulty level in writing the program. So writing a good multi-threaded application or multi-threaded code is also a little difficult and requires skills and experience. It could result into unpredictable results as well because you don't know how the threads will execute, what are their order of execution. So if not handled properly, that could result into unpredictable results as well. Next is how to detect a deadlock in Java. So deadlock can occur if there are at least two threads and at least two resources. So when testing code, a deadlock in Java will read as logged resource in the command line interface. You can detect a deadlock in Java by looking at the thread dump. So we need to analyze the thread dump. We can generate the thread dump and analyze it. We can even use command to generate the thread dump with some operating systems as well. You can view it in the command line interface or download it as a text file also for the review and references. There are multiple tools, one of which is like fast thread to analyze the thread dumps with ease. So you will be able to see logged resources under the threads which are actually locking the resources. The next question is, what is ternary operator in Java? So this is one of the very useful operator. Suppose if we want to test some condition and if we want to perform one operation when it's true and another operation when it's false. So what usually we do, we write if and then else. So the ternary operator is kind of replacement for that. A ternary operator evaluates the test condition and execute a block of code based on the result of the condition. So this is how its a syntax is. First it will check condition, then we have question mark, then first expression if that condition is true. If that condition is not true, then the second expression will be called. So let's take an example. Suppose we have one variable marks, which is integer. Its value is 90. If the marks are greater than 33, we want to set the result string as pass. Otherwise, result string should be assigned as fail. So using ternary operator, we can do it in a single line here. So here what we are doing, marks greater than 30, enclosed it in the brackets, so that it can result into either true or false. So marks can be either greater than 33 or less than or equal to 33. So this should result in a true or false value. If it is true, then result will store pass as a string. Otherwise, fail will be stored in result. So this is how you can use the ternary operator in Java. The next question is when to use ArrayList and LinkedList. So both ArrayList and LinkedList, they store the element as list. If searching is more frequent operation than adding or removing, then ArrayList is the better option, because ArrayList provides constant time for search operation using the direct index number. So in case of ArrayList, if we want to access the 100th element, we can directly provide the index of that element and it will return us the value. But if more operations are happening on the array list, that means the list in the list itself we are trying to add or remove a lot. In those cases, array list becomes a bottleneck in performance. So in those cases, the linked list provides the constant time for adding and removing operation. So it is better to use linked list for the list manipulation in case add or remove is there. Next question is what is hashing in Java? This is very important concept. So what exactly is hashing? So hashing is a concept which involves mapping of objects to the integer value. So suppose I have an object student, it is having name, roll number or some other fields. So if I want to map that particular object to one specific integer value, then I will use hashing. These values are called hash values. Whatever the integer value is there, those are known as hash values or hash codes. The hashcode method in Java is used to compute the hash values of Java objects. So hashcode method is already available in object class. So automatically what it will do, it will take one object and it will convert it to a specific integer value. The hashcode method is used to generate the hash value of objects. Using these hash values, these objects are stored in Java collections such as hashmap, hashset, and hashtable as well. There is a relation between object equality and hash codes. So if two objects are equal as per equals implementation, then they must have the same hash code. But two different objects can also have a same hash code. So what does it mean? Suppose there is one object and no matter how many times I am calling hashcode method on that particular object, it should result into the same integer value. And if that object is equal to some other object as per the equals implementation, then the hash code generated should also be equal. This is also one of the very important question that we will cover in our one of the next videos, like what is the contract between equals and hash code methods in the Java objects. So with that, let's come to the last question of this video. How the JVM handles thread synchronization. So to coordinate shared data access among multiple threads, the JVM associates a lock with each object and class. A lock is like a privilege that only one thread can possess at one time. So that if one thread is already having the lock of that object or class, no other thread will be able to access it. If a thread wants to lock a particular object or class, it asks JVM. When the thread no longer needs the lock, then that will be returned back to the JVM. If another thread has requested the same lock, the JVM passes the lock to that new thread which is requesting the access. So this is how, using the locking, the JVM handles the internal thread synchronization. So with this, we have come to an end of this video as well. So if you like the video, please do like, share and subscribe. And also don't forget to press the bell icon. Do share these videos in your community so that everyone will be able to get the benefits. In case any question is not clear or if any improvement is required, please do comment. So we will come up with more questions in our next video. So till then, keep learning,